Welcome back to 39 Weeks Benchmark. I'm going to try to do a video on EE4. There's 4 problems. They all involve inequalities. Inequalities confuse a lot of folks still. So I'm going to make sure we hit inequalities in class so we know what's going on. Number 12 is at the top of the second page and it's been cut off. It says if R, and this is actually not inequalities, this is making expressions. It says if R is 3 less than twice t, which of the following is true? Okay, R is 3 less than twice t. R is always an equal sign. R equals. So I'm going to write R is. I'm in luck, every single one of them starts R equals. Then we have this phrase, 3 less than twice 6. No, t. I can't read my own handwriting. 3 less than twice t. Lord, my handwriting and my brain don't go together. 3 less than. That means I would take 3 away from something. What am I taking 3 away from? Twice t. Twice t is 2 times t. 3 less than twice t. 3 less than is 3 less than. Twice t is 2t. And I've got D right away. Number 12. All right, what's next is number 30. Number 30 is inequalities. Oh no, it's not. Look, it's an equation. I've lied to you already. Every day of the week, Jessica earns $10 per hour. So you multiply 10 by how many hours she works. She also earns a bonus of $15 if she babysits each day. I'm assuming it's going to say if she babysits each day. You see, make sure I haven't missed the word, because sometimes they cut it off on the side. Yeah. Oh, so her weekly bonus is just $15 straight up. So $10 per hour. She works every day, so she gets her $15 bonus, and she earned a total of $225 for 8 hours of babysitting. So based on the statement, what's true? Well, you could write an equation to model it. You could say she's going to earn $225 because she spent, say, $10 per hour. That's 10 times H, and she got her $15 bonus. So logically, like, the way you solve the equation is going to be just the way you'd solve it without writing an equation, but sometimes it's nice to see it written out as an equation. Okay. I got $15 as bonus. She got $15 as a bonus. The total she got was $225. So we're going to go backwards. We're going to figure out what's 15 less than $225. And that's what we're going to do over here. We're going to say, well, I just want the variable part. So what's minus 15? That'll get rid of it. 15 minus 15 is 0. We're down to just a $10 times the hours. We get $210 there. So if I have $210 and I got $10 for every hour, how many hours do I have to work to get $210? Well, divide it by 10, because that's how much she makes per hour. And you find that the hours is going to be 21. You can also just try to power through and guess and check and see what happens. 10 hours. $10 per 10 hours is $100. Plus or $15, that's not going to be it. 20 hours times 10, that's 200. Plus 15, that's 215. That's kind of close. 21 times 10, 210. Plus 15 is 225. Ah, that's it. If you tried 23, you got 230, 245. That's too much. There we go. No, my laptop's about to die. I need to see my originals. 37. Keegan's a waiter. Oh, we've done this problem in class. He earns $8 per hour plus a $5 bonus per family he serves. He serves 13 families. All right. So he needs to have $8 times H hours. So 8 times H. He also needs to have a $5 bonus per family times the 13 that he serves. So 5 times 13 is 65. He wants to earn a minimum of 150, so a minimum of 150. He wants to earn more than or at exactly equal to 150. So there's actually four different options. And this one here, like C, is 8.0h plus 65 is less than or equal to 150. And D is 5h plus 65 is less than or equal to 150. So the less than or equal to, he doesn't want to earn less than 150. He wants to earn at minimum 150. So he could earn more than 150 and still be happy. Those guys are going to roll out right away. The 8 goes with the hours, so it's got to be A. You could solve it for this, or you could just not, because this one you don't need to solve. That's all you need to do. That's the only option where you have 8 with the H, and you're going to want to have at least 150, a minimum of 150, no less than 150. Number 70. Number 70. All right. There it is. Click on the inequality and drag it to the graph that shows the solution. So I'm going to hit A, B, and C on here so we can follow along. A, B, C. All right. So the way to solve an inequality is kind of the same way as solving an equation. There's only one major difference, and if you divide both sides by a negative number, you've got to change the direction of your sign. If I have a negative number or I divide it by a negative number, it's now going to be positive. I'm going to flip the direction that it's going. So we got a couple options on solving these logically. You could look at where these dots are. Notice all the dots here are solid, and sometimes we have them that are open. Solid dots mean you're going to have the or equal to sign. It's going to be less than equal to, greater than equal to. You're going to have that underline underneath your less than equal to, or your less than or greater than signs. If you have one that doesn't have an underline, it's going to match up with one that has, instead of a solid dot, it'll have an open dot, and then shaded everything where it's supposed to go. So open dots, you're not going to have the equal sign underneath those guys. All right, but since these are all greater than, like, that doesn't help us. It doesn't help us discern anything. We're lucky that there's only 3 of them, so I could solve 2 of them and then match the third with the missing one, if we want to. So let's start at the top. Negative 4x is greater than or equal to 12. This is a one-step equation. I don't have a constant with this side. I just have a variable term with a coefficient. Over there's my constant. I have negative 4 times x. To undo multiplication by negative 4, let's divide by negative 4. That'll leave us with 1x. If I divide by negative 4 on the left of this relating sign, I need to divide by negative 4 over here. 12 divided by negative 4 is negative 3. I'm going to stop here and check and see. Yes, I've got negative 3, I've got 1, I've got negative 2. So A is going to go with this guy. But you might run into the problem where you've got like a less than negative 3 or a greater than negative 3. There's 2 options that have negative 3 as an endpoint. You got to be very careful then about this sign changing. If I divide by negative 4, everything here that was negative is now going to be positive. So my direction switches. So I've got to switch this guy to less than or equal to. So that makes sense. Less than is to the left. Let's look at B. I got 3x plus 7 is less than or equal to 10. I have a variable term with a coefficient, and I've got a constant term here. And I got a constant on that side. Let's get rid of the constant here so we have this situation, just have to divide. I have plus 7. Let's subtract it. Because positive 7 minus 7, that makes 0 on this side. We have just 3x left over. 10 minus 7 is 3. And the good news is, this is not dividing by a negative number, so I don't have to flip it. I'm just subtracting something. 3x divided by 3. 3 divided by 3 is 1, so I have x is less than or equal to 1. Happens to be this guy. So C is this guy. You want to see how this one works? It'd be 5 minus x less than or equal to 7. Let's subtract the 5 for both sides. So we have just a minus x. Be very careful, because if you've got a negative sign, that's got to stick with that term. 7 minus 5 is 2. This is a negative 1x, so let's divide by negative 1. Now I'll get rid of that negative sign. 2 divided by negative 1 is negative 2. I divided by negative, so greater than or equal to negative 2. And that's correct. That's it.